So how to model source in PSCAD? Just to proceed with any other simulation, any other study, we need to model the source. First, we will see how to model the source from PSCAD library. So I have created one space, and we will bring that source from the master library. You can see this is the master library, and here it is more on sources. We can pick up from here different type of sources are there. First of all, these are the that type 1, type 2, type 3. These are different sources. As you can see, this is voltage source model 2, means model 1, model 2, and model 3. This is model 1, this is model 3. So these are the voltage sources, and there are current sources as well, like this is current source, this is also current source. So what we are going to do, we are going to model one typical source. Let's say this voltage source. Just copy this and paste it here. Yes, now we can see this source. We can rotate, and here you can see this is external voltage and phase, voltage magnitude and phase. So what we need to do, go to component tab. From here, this thing we need to assign. Let's say this is 400 kV, and what is the magnitude? Zero. This is the phase angle, not magnitude. Phase angle, magnitude is 400 kV and angle is 0. So 400 kV, angle 0, and we'll specify the model also, means the values. Let's say this is typical source 1. Source name, you can change the source name, you can change the source name also. 100 MVA typical, this is the base MVA. You can change this 100 MVA also. We are not going to change this, but definitely we are going to change this from 230 kV, which is the default value, to 400 kV. It is there, and we are considering 50 Hz system. Infinite bus, whether it is infinite bus, let's say consider this as infinite bus. At a later date, we can consider different source impedance, different based on different short circuit level. Right now we are considering as infinite bus. Graphics display, single line view or three phase view, you can change it from here. Let's say this is single line view. If you want to display the details, then it will be put on yes. Display details means this Z1 means resistance value, reactance value, this MVA, frequency, voltage, so all these things. So if you put yes, it will be shown here. If it is no, that means you can see it is not there. So you can specify this. What are the parameters we have specified? 400 kV, 50 Hz system, 100 MVA. And since why this resistance and reactance values are not showing here, because we have considered as infinite bus, so it is not considering this positive sequence impedance or this zero sequence impedance, all these things. So now source modeling is done. It's a simple source modeling where we are considering as the source as the voltage source as the infinite bus. So we are done with the source modeling. Now what we will do, we will connect it to a bus. Here you can see the bus. So let's say this is also 400 kV. You can give the bus name also, right? So 400 kV bus, and okay, space is not allowed. 400 kV bus, now it is allowed. And what is the kV? Bus voltage is 400 kV. Now the color is also changed. Just connect it using the wire mode here. Now what we will do, we will validate this source, this 400 kV, this voltage magnitude here in this 400 kV bus. So since this is infinite source, so we should get the 400 kV in this 400 kV bus. So for that we need to use let's say multimeter. We can use multimeter. And maybe for phase voltage measurement we can use another meter. Let's assign this multimeter. What we want to measure from this multimeter? Instantaneous voltage. Yes, just put yes. Only the voltage, because current measurements is not required, because there is no load connected or any other sources, or so all these things. So active power flow, reactive power flow, all these things are not required. This will be required during the next sessions, where I will show how to connect the loads and how the power is flowing, that active power, reactive power, what is the current, RMS current, this instantaneous current, all these things. Now only the instantaneous voltage that will be sufficient, right? So now we need to specify the signal name here, only instantaneous voltage, and here we need to put the signal name instantaneous phase voltage or line to line voltage. We are going to measure the instantaneous line to line voltage. Just you can put VLL instantaneous. Okay, and here we need to measure that V line to ground means phase voltage, and that is instantaneous, right? So from this multimeter we are going to measure the instantaneous voltage, instantaneous three phase voltage, and here the instantaneous phase voltage means line to ground. So now if we run the simulation, nothing will happen, means we are not able to see anything here. There will be no plotting available here. Still, let's run and let's say whether it is converging or not. So actually the simulation already started. If we run once again, it is running and the simulation already completed, but we are not able to see anything here. You can see we are not able to see anything here. So how to view that, that measurement, this voltage, instantaneous voltage and phase voltage? So for that we need to do one thing. Go to components tab over here, and there is a signal. This is the signal channel, and here the same signal name what we have assigned here, same signal name we need to mention here also. and with that we need to plot the voltage and connect it using the wire mode. And here what we want to do, let's give the name here, the line to line voltage, instantaneous voltage, v line to line, instantaneous, and here nothing is required, only this thing. So still it will not show anything. Let's run once again. Yes, simulation is completed, but it is not showing anything. So how to plot that? Again, for that we need to use the graph here. Graphs, here we can use anything. Let's say add overlay graph with signal. If we want to see this, so this is one graph, and here we can give the unit name also. Unit, it is in kV, right? This will be the instantaneous voltage, so it is in kV. So now if we run this, yes, simulation is completed, and you can reset this curve. Then you can press M for measurement, and you can check here. This is maximum voltage. This is 565.492 kV. 565.492 kV. So how it is coming? We have given this 400 kV. Now it is 565 kV. So how it is coming? Let's say VLL line to line voltage is 400 kV. This is 400 kV, and what we can see here in this graph, this is the peak value. So what to do? B peak, that will be square root 2 into this. Sorry, I made some mistake. Square root 3 into 400 kV. So it is coming 565.685, right? 565.492. So it is almost matching. There will be slight difference, which is it's a simulation software. So it's coming 565.492, 565.685. There's a slight mismatch with respect to the simulation, but it is matching in this way. Now let's measure the line to line RMS. It should come, ideally it should come 400 kV. So let's measure the RMS voltage also. So how to measure that RMS voltage? Using the component tab here, this is the data tab, and we can we can use from the RMS, maybe from meter. Yes, this one, just copy and paste. Digital 50 Hertz, that's all. And we need one channel like this just to see the plots. And what will be the name here? Let's say this is V, line to line voltage RMS. That's all. And we need that graph also. We need the graph also. Yes. So here what we can see, this what will be the unit here, we can assign from here. This is also in kV, this is also in kV. So now let's run the simulation to check the RMS voltage. Reset the graph. Now it is coming. Press aim for measurement, and now check what is the voltage here. 399.992, right? Make it bold. So this is 400 kV. Ideally it should come as 400 kV, so it is coming 399.992, so very close to 400 kV as per the simulation result, right? So this is 400 kV is validated line to line voltage, and peak value also 565 kV, that is also validated. Now what we will do, similarly we will validate this one also, means line to ground voltage also, that is phase voltage. So how to do that? Similarly we can do signal, put the signal name here like this. We need one channel to plot that, connect it via wire mode. Also if we want to check that RMS, we can just copy from here this the RMS, another channel. Yes, so what will be the unit here? Obviously in kV. And what will be the name? This is instantaneous, V line to ground instantaneous, and this one unit in kV, V line to ground RMS. This will be RMS voltage. And we need the graphs to plot. This is one, and another graph, this one. Yes, we are done. So we will run this. Just to validate line to ground voltage, instantaneous voltage and phase voltage, means instantaneous and RMS voltage. Simulation is completed, but the curve is not coming exactly. So what to do? We need to reset this. measure, and we can see this is 326.599, 326.599, and here it is. What is the value here? This is the RMS voltage is 230.936, 230.936 kV. It is in kV. This is line to ground RMS. This is line to ground instantaneous. So now let's validate these two values with respect to the manual calculation. So how the second value is coming? Firstly, this RMS voltage 230.936. How it is coming? Because our line to line voltage is 400 kV. So what will be the line to ground RMS? That will be 400 kV divided by root 3, right? So it is coming 230.94 kV, 230.94 kV. So it is coming 230.936, means 0.94. So it is validated. Now we will validate this peak value, this instantaneous, line to ground instantaneous. So let's validate this. What will be the line to ground instantaneous? That will be equals to root 2 into RMS, root 2 into RMS. So it is coming 326.599 kV, 326.9599 kV. Let's check with our simulation result. It is coming 326.599. So let's take a snap and paste it. So 326.599, it is coming 326.599. So it is exactly matching. And RMS 230.94 kV, here it is 230.936, means 0.94. So it is also matching, right? So in this way we have validated using one infinite source, voltage source. We have validated using that 400 kV source what is the instantaneous and RMS voltage, three phase and single phase. So in this video, up to this,